My name is Sridhar GR, Assistant Professor, Government First State College, Kolar. Today I am going to discuss theorems on moment of inertia, that is in session 3. There are two theorems of moment of inertia. First one is parallel axis theorem. The second one is perpendicular axis theorem. So theorems on moment of inertia, that is parallel axis theorem. So this is a rigid body. ICM is the moment of inertia, an axis passing to the center of mass. This is the center of mass. This is an axis passing to the center of mass. The moment of inertia about this axis is ICM. Again, the moment of inertia about any parallel axis, about any axis parallel to the axis passing to the center of mass is equal to moment of inertia about the center of mass and product of mass of the body and square of the distance between the two axes. So here, according to parallel axis theorem, the moment of inertia of a rigid body about any axis is equal to sum of the moments of inertia about a parallel axis through its center of mass, and the product of mass of the body and square of the perpendicular distance between these two parallel axes. Here, let I be the moment of inertia of a rigid body about a perpendicular axis z1, z1 dash. So this is the moment, I is the moment of inertia about an axis, that is perpendicular axis z, z1 dash. Let Cm be the center of mass of the rigid body. This is the Cm, center of mass of the rigid body. And ICM be the moment of inertia of the rigid body about an axis z, z dash through Cm. That means ICM is the moment of inertia about the axis passing through Cm. Consider a particle of mass m, that is consider a particle of mass m which is at a distance x from the center of mass. The moment of inertia of the particle about z1, z1 dash is I, which is given by I dash is equal to m into x plus d whole square, because moment of inertia is given by product of mass and square of the distance of the, this is the moment of inertia of the particle, that is I dash is equal to m into x plus d whole square. So the moment of inertia of the whole rigid body about z1, z1 dash is I is equal to summation. This is the moment of inertia of the particle. This is the moment of inertia of the entire body or whole body, that is I is equal to summation m into x plus d whole square. So this x plus d whole square is nothing but x plus x square plus d square plus 2xd. That is, this can also be written as summation mx square plus summation md square plus summation 2mxd. That is, summation md square can be written as summation md square. Summation m is nothing but mass of the whole body, that is m into d square. Again, this is summation md square is that is moment of inertia of the ICM is nothing but moment of inertia, that is summation mx square. Therefore, the moment of inertia of the whole or entire body is given by I is equal to ICM plus md square plus summation 2mxd. So the rigid body will balance itself about the center of mass. Center of mass means it is the point in a rigid body where the entire mass of the body is assumed to be concentrated. That means the body is in equilibrium about that point. Therefore, the algebraic sum of moments of the weights of the constituent particles about the center of mass should be 0. Therefore, summation 2mxd is 0. Therefore, that is summation mx is equal to 0. Therefore, moment of inertia of the entire body about an axis passing through the is equal to I, that is equal to ICM plus md square. Therefore, the moment of inertia of a rigid body about any axis is equal to sum of the moments of inertia about a parallel axis through its center of mass, and product of mass of the body and square of the perpendicular distance between the two parallel axes. Hence, that is parallel axis theorem is proved. That is I is equal to ICM plus MD square. Next is perpendicular axis theorem. Say this perpendicular axis theorem holds good only for the plane lamina. Here the moment of inertia of a plane lamina about an axis perpendicular to its plane, that is an axis perpendicular to the plane, is nothing but OZ, is equal to sum of the moments of inertia of the lamina about any two mutually perpendicular axes in its own plane. That is, one is OX, the other is OY. These are the two perpendicular axes, that means which are in the plane of the lamina. These two are perpendicular to each other, again intersecting each other at the point through which the perpendicular axis passes. That means here the moment of inertia, this OZ, is an axis passing to the that is which is perpendicular to the plane of the lamina. Again OX and OY are the moment of inertia or axis passing to the in the plane of the lamina, but all these three axes are at the same point. That means they are intersecting at the same point, that is O. Let plane lamina consists of particles of masses m1, m2, m3, so on to mn at perpendicular distances r1, r2, r3, so on to rn from OZ axis. We are considering this body is consisting of so many particles of mass m1, m2, m3, so on to mn at distances r1, r2, r3, so on from perpendicular axis, that is OZ. The corresponding perpendicular distances of these particles from OX and OY are y1, y2, y3, so on to yn, and x1, x2, x3, so on to xn respectively. Then we know moment of inertia of the about the x-axis is given by Ix, that is equal to summation I is equal to 1 to n mi yi square. About y-axis is Iy is equal to summation I is equal to 1 to n mi xi square. Iz is given by summation I is equal to 1 to n, that is mi ri square. Therefore, that is Ix plus Iy is equal to summation I is equal to 1 to n mi yi square. Again summation I is equal to 1 to n mi xi square. Here Ix plus Iy is equal to summation I is equal to 1 to n mi into xi plus xyi square. But from the figure it is clear that xi plus xi plus xi square plus yi square is nothing but what? Ri square. Therefore summation I is equal to 1 to n mi ri square. This term is nothing but what? Iz. Therefore Ix plus Iy is equal to Iz. That is the moment of inertia of a plane lamina. About an axis perpendicular to the moment of inertia of a plane lamina about an axis perpendicular to its plane, that is OZ, is equal to sum of the moments of inertia of the lamina about any two mutually perpendicular axes in its own plane, that is OX and OY, intersecting each other at the point through which the perpendicular axis passes. Hence perpendicular axis theorem is verified. Thank you.